Hi, hello, welcome all of you to my YouTube channel Connect to Physics. Dear students, now today we are going to discuss one more important topic, that is Reddy Shock Tube. Okay, so every day in our life we ride our bikes. Okay, when you're going to horn your bike, one thing you might have observed, the horn speed is greater than the speed of your bike. That means speed of the sound is greater than speed of the object. So in the case of lightning, okay, when the lightning is happened, at that time the speed of the object is greater than speed of the sound. That means first you will observe the light, afterwards you will hear the sound of that lightning. So that phenomena we are going to consider as a shock wave. Okay, shock wave is nothing but which create high pressure and high temperature, and the speed of the object should be greater than speed of the sound. That is called as shock wave. Okay, now in today's class, if you want to generate shock wave in laboratory, we are going to use Reddy Shock Tube. Okay, so in today's class we are going to discuss its construction as well as its working principle. Okay, now moving on to the topic. This is a semantic diagram of Reddy Shock Tube. First we will discuss its construction. See, in the construction, this Reddy Shock Tube, which consists of piston. Okay, so here we have a piston. This piston is fixed to the driver gas. Okay, this is the driver section. Now in the Reddy Shock Tube, the first important thing, how we are going to define this Reddy Shock Tube means, it is a hand operated shock tube capable of producing shock wave by using human energy. Okay, by using human energy you are going to make a shock waves. So now we'll discuss one by one its important parts. This Reddy Shock Tube, which consists two section, one is driver section, another one is driven section. Far end of the driver section is connected to the piston. Okay, and here we have mounted a pressure gauge, okay, on this driver section, and two pressure sensors are mounted to the driven section. Okay, so these two section, driver gas, a driver section and drive one section, are separated by a metal diaphragm. Okay, this separated by a metal diaphragm. Okay, this is the metal diaphragm where these two sections are separated. So inside the driver section we are going to use the driver gas. So this driver gas is a very high pressure gas. Okay, note this is a high pressure gas. And inside the driven section we are going to use the test gas. It is a low pressure gas. Okay, you have to remember these two things. And for this driver section, this end we are going to call it as an upstream end, and this end towards to the driven section we are going to call it as an downstream end. Okay, so these are the important parts of Reddy Shock Tube. Now moving on to the construction. In the first point, when we have seen this figure, at that time we have its diameter and its length. So that's why the diameter of this Reddy Shock Tube, which is made up of stainless steel. Okay, this Reddy Shock Tube which made up of stainless steel, the diameter of this tube is 30 mm. Okay, the diameter is 30 mm and its length is 1 m. Okay, this is the diameter and this is the length. Okay, so diameter of this Reddy Shock Tube is 30 mm and the length of this Reddy Shock Tube is 1 m. And the diaphragm, okay, this is the metal diaphragm which separates these two sections. The thickness of this metal diaphragm is 0.1 mm. Okay, this is the thickness of metal diaphragm. Okay, so next, this is the third point, and the fourth point is, far end of the driver section we have connected a piston. Okay, so inside the driver gas you are going to inside the driver section you are going to use driver gas, and inside the driven section you are going to use the test gas. Okay, so this is about the construction of Reddy Shock Tube. Now moving on to the working principle, what exactly happened means, see, when you are going to move the piston, we know that why we are going to use the piston means to move the up and down of our engine parts. So that's why we are going to use the piston. The working of piston is to move engine parts up and down. Okay, so when you are going to move this piston, So this is connected to the driver section. Inside there will be high pressure gas. Okay, so once this piston will compress, okay, this compress to this driver section. So what happen, once it will compress to this driver section means it is applying some force towards to the driver section. At that time what happen, inside the driver section there will be a gas molecules, those are in high pressure. Okay, so due to that compression, due to the force of the piston, they start moving towards to the driven section. But one thing is there, in between the driven and driver section there will be a metal diaphragm. Okay, so due to the pressure which is produced by this piston, these gas molecules again and again they will hit to this metal diaphragm. Okay, so once they will hit to this metal diaphragm, slowly what happen, this metal diaphragm will get ruptured. Okay, so once it will get ruptured means what happen, these gas molecules are going to enter towards to this driven section. Okay, so at a particular time what happen, completely this metal diaphragm will get ruptured. Okay, so once it will get ruptured, slowly what we are observing means the shock waves are producing from this driven section, and the pressure of this shock wave we are going to measure with the help of this pressure gauge, and the pressure which is detected from this pressure sensor. Okay, so once it will get rupture, this metal diaphragm, these gas molecules which enter towards the driven section. Okay, so once it will go to the driven section, what happen, it will hit to the end of this driven section. This is the closed end. Okay, this is closed end. So what happened, due to the pressure it will hit, and afterwards these gas molecules which come towards to the downstream end. Okay, so again what happened, these gas molecules will go like this and again they will come back. So when the molecules movements are created, at that time they produce the shock waves. Okay, so that's generate a shock wave. So this is the working principle of Reddy shock tube. Now if you want to see the exactly what are the properties of Reddy shock tube means, this is an hand operated shock tube, first thing, and second thing, this Reddy shock tube capable of producing match number 1.5. okay, you have to be note this match number, they produce 1.5 match number. And third thing, 900 Kelvin. Okay, 900 Kelvin of temperature easily obtained by using this Reddy shock tube. Okay, so this is the property, these are the important properties of this Reddy shock tube. And we know that shock waves are very important. They can use we can use shock waves for the treatment of orthopedic disease. Okay, also you are going to use shock wave to the disintegration of kidney stones, and also you can use these for the medical purpose to push DNA inside the cells, and also for the pencil industries. So these are some important applications of shock wave. Okay, I hope all of you have understand this topic. If you like my video, share and subscribe. Thank you for watching.